So today we are going to see modeling the physical world for immersive environment. Can everyone see the screen? Is PPT visible? So first one is how we create the similar world that is related to the real world environment. So we need to create a digital representation, right? We need objects, 3D objects to create the physical world that will reflect in the virtual space which we are going to create, right? So here we are using different immersive technologies. What are the technologies we have? We know, right? One is virtual reality, other is augmented reality, and the last one is mixed reality. So in this modeling the physical world, what we are going to do is we are going to design the digital model so that will allow the users to interact with the virtual world which is designed using the physical world measurements or physical world that will reflect in the virtual world, right? So in this modeling what we are going to do is we are going to design a digital model that will allow the users to interact and experience the world which is created virtually. So that is the representation of the real world which we are present, right? So why physical modeling is so important is we need to create in a more realistic way so that we feel like it is the real world which we are experiencing in a virtual space, right? So this is the most important thing in the virtual reality and in augmented reality, how we are going to reflect the real world objects or the physical world objects in the virtual space or virtual environment, right? So here we are going to build an accurate same like a real world objects in the virtual space, right? Virtual environment. So here how we recreate the real world objects and locations, how we are going to interact and how we are going to enhance the sense of presence and immersion is very important while we are modeling the physical world. So what are the techniques we use for modeling the physical world? So first one is photogrammetry. So in this technique we will be involving different multiple photographs so that that particular object or environment will have different angles, right? So by using a specialized software we will be using all these multiple photographs and we'll reconstruct a 3D model based on the visual data which we are capturing through photographs. So this technique is commonly used to create detailed models that will depict buildings, landscapes, or real world objects. So that will be like more realistic when we create by using this photogrammetry technique. And the other technique is lidar scanning. So in this scanning we will be having the light detection and ranging so that we can scan and use the laser sensors to measure what what is the distance and how we create a 3D point or an object or an environment by using this light detection and ranging technique. So this is often used for representation of large scale industries environments like buildings, cityscapes. So here we will be capturing detailed and accurate representation of that particular buildings if we are going to design in virtual space. And the next technique is 3D modeling. So here we know in 3D modeling we will be creating virtual 3D objects in the environment by using some software in a computer. So this technique will allow the developers to manually design and construct digital objects. So here we will be developing manually the design and how to construct digital objects, right? By based on the objects or the environment, how we are going to measure what are the specifications. and how we are going to interpret that particular object, right? In 3D modeling technique we are going to see all this. And real time information integration, it is like we are going to integrate real time information into our virtual world, such as if you see for an example, if we are taking live video feeds, so that is a real time which we are going to interact with the virtual environment which we are going to experience, right? So in that we will be integrating with this sensors data or live video feeds, so that we can experience that particular immersive technology. So it will be very interactive and it will be very real when we come into that virtual space while we are experiencing, right? So if you take for example, in augmented reality we have a car where we can locate each and everything, the environment when we are traveling in the car, right? So we can take that particular data and we can dynamically update how virtual we can represent in the physical world. So if you take the directions or the how we are, which route we are going to go, that and all, it will be displayed in your cars, right? If you take the augmented reality example, real time information integration we have used, right? So what are the applications we use for this modeling the physical world? So definitely we will be using in architecture and design. So it is virtually used to create immersive walkthroughs. So if we are using any projects or if we are doing any proposals that should be built using architecture and design, first we need to explore, we need to walk through that particular area or to that design, how it is going to be builded, right? So if the client want to experience and interacted to that buildings which they are going to create or build, they need to experience it by using this modeling the physical world. So the next one is training and simulations. So we have so many training simulations, right? Aviation, healthcare, and military we have seen, right? So this will give accurately how we are going to model the physical world, so that the trainees will experience the real world scenarios in a safe and controlled virtual environment. And mostly it will be used in entertainment and gaming, so that it will be very interactive while they are playing with the physical and virtual worlds, right? So here we can use a real world locations or objects within the game environment, right? So if you take the Pokemon Go, we will be keeping the 3D objects on the real world so that we can experience and interact with that Pokemon Go game, right? So if we take education and cultural heritage, so in education it will be mostly useful to students and to explore how the historical sites or how the scientific concepts that they can experience by using this virtual reality and augmented reality, right? So it will be very engaging in educational content if we are using this. So these are the techniques, applications, how we are going to use to model the physical world, right? So the next topic is managing multi models in 3D world. So here we need to manage multi models when we are creating a 3D world to experience VR, right? So here we need to organize first and we need to integrate with various 3D models so that it will be more effective. And we should ensure while we are making this 3D models with multiple models, we need to properly position it and we need to interact it with proper experience or proper guidance, and we need to visually consistent interactable with that particular virtual environment which we are going to use to experience, right? So we have few techniques how we are going to manage multi models in a 3D world. So first one is model organization and hierarchy. So how we are going to organize our 3D models? First we need to facilitate management and then we need to interact. So what are the hierarchies that have relationships between different models? So we have parent child relationships and spatial grouping. These both are the hierarchies that we use in model organization and hierarchy. So this both hierarchies will help us for easily manipulate and interact with the models within that particular virtual environment. So if you take spatial placement and positioning here, what we are going to do, we are going to position the 3D models accurately within that particular environment which we are going to create, right? So in this, we are going to use techniques like spatial tracking and scene understanding or marker-based tracking, so that we can determine which position and what is the orientation of the models relative to the user's perspective. So here we need to align the real-world environment in the context of virtual environment, right? So here the real-world environment we are going to align them in the virtual environment. So the next technique is how we are going to interact. That is the main thing, right? When we are creating a virtual environment, interactivity is very important. So when we create with 3D models, so it will enhance the user's engagement and how they are experiencing the immersive technology, right? So while we are interacting, we can see object, how we are going to manipulate it, and what is the physical based interactions that we are doing. These are the interactions that we see. So if we are interacting with the virtual world, we can rotate there, or we can grab the 3D objects, or we can touch, and that we can sense, right, whatever we are doing in the virtual environment. So we can animate the models based on our input, right? So the next technique is level of detail. So while we are considering this level of detail in 3D models, we need to balance the visual quality and performance. So here the scene which we are creating is very important, right? So that it will be attractive and intuitive to the user which we are going to create, right? So this technique will be used for simplified versions of the models. So here we can have the textures for distant or less important objects. So this optimization will help in maintain the objects in a smooth and responsive way, so that we can experience it in a constrained environment. And the next technique is lightning and shading. So whenever we create a 3D model, lightning and shading is also important, because it should not affect our eyes, right? So when we are using the appropriate lighting techniques, so that it will give the illumination to create it in a realistic way, right? So we will be using a shader so that we can achieve the proper reflection or the shadow or surface properties to the models which we are creating. So it will help us to improve the visual quality, right? And the next one is model loading and streaming. How we are going to load and stream the 3D models, so that it will optimize the performance, right? So here we will be loading and streaming different by using level of detail streamings, right? So here the user's point of view and interaction is very important while we are loading and streaming the 3D models with multiple models, right? So this approach will help us to reduce the loading time, and it will allow the memory utilization efficiently. So the next technique is collision detection and physics simulation. So we all know what is a collision detection, right? So collision detection is nothing but whenever two 3D objects or objects both come together or clash in the virtual space, it collides, right? So their collision will occur. So here we have to implement collision detection and physics simulation so that it will be very interactive and it will be very realistic when we are creating the 3D models. So here the object interactions and object manipulations will help us to reduce or avoid collisions, right? When we detect collision we can avoid it, right? So it will be helpful for creating more immersive and engaging simulation tools if we create in this way by using all these techniques. So the last one is model versioning and updating. So we will be having different versions of models, right? So whenever a new version comes, we will update the 3D model within that environment so that whenever we keep on changing or updating it, it will replace with the existing models with new versions, right? So here this is the last technique that we use in multi models for creating 3D world. And the next one is kinematics modeling. So kinematics is, it is like a study where we use the modeling of the movement and the motion of objects or characteristics within the virtual world. So here the movement and how the object is moving in that particular model and what is the characteristics of the object is very important in kinematics modeling. So here we need to understand how the object or the characters that move, their positions, orientations, and how they follow in the 3D world. It is more important in kinematics modeling. So here in kinematics modeling, it is also used for creating realistic and interactive experiences for users. So here we have different types of kinematics, that is forward kinematics, inverse kinematics, motion capture and physics simulation. So these all techniques will help us to simulate it accurately and represent object movements how it is working in physical modeling. So by using this kinematic modeling we will be getting the responses of users interactions and animating avatars, and we will be enhancing the sense of presence and realism in immersive environments. So if we take the object kinematics, here the object and the characters that need to move and interact very realistically. So it will be involving how we are defining a position and an orientation and motion of objects based on their physical properties and user input which user is going to give, right? So here we have a different techniques. We have seen forward kinematics, inverse kinematics, or motion capture. So how user is going to interact in kinematics modeling, right? So users will be interacting mostly with the objects that is created in the virtual environment. So here we can use the hand tracking or gesture recognition or motion controllers to capture the user input so that we can map that particular data in the into the motion of the virtual object which we are using in the virtual environment. So this will help us to interact easily with the users, and it will help the users to experience it more realistic and it is more engaging. And the next one is avatar animation. So we all know by using the physical world user movements we can re- replicate same as in the virtual environment, right? So that representation we can make it as avatar representation also. If you see, you will be using few avatars in your mobiles. For example, if you want to share any animated images or something in your mobiles, you will be using mostly avatars, right? So how we animate and how we control those movements by using these avatars, it is like basically used the moment which users are going to give input or how they are going to move in physical world, that should replicate in the virtual environment, right? So that we can align similarly in the virtual space. So if you take techniques like skeletal animation or blend trees or different animations, that will help us to give responsive avatars within this particular immersive environments. So if you take the physics simulation, so here we will be using gravity forces and other physical phenomena within the virtual environment to create the interactions between objects and the characteristics. And we will be helping the physical simulation by providing necessary movement calculations of object and characters based on their physical properties, which we are going to use for 3D objects, right? And the next one is performance optimization, and the last one is real time feedback and visualization. So here in real time feedback and visualization, we will be taking the movement of that particular object within that virtual environment, and this will we will be using motion trials or visual indicators to help users how they are going to interpret with the movement of objects, right? So here the perception of users how they are moving and how they are improving the ability to interact with the virtual world is very important while we are using this real time feedback and visualization technique. So homogeneous transformation matrices for immersive environment, this topic will come under kinematics modeling. So these matrices are used to represent how the position and the orientation of the object and characteristics within the virtual world. So these matrices will allow the transformation of coordinates between different coordinate systems. So here we will be having the accurate positioning and movement of objects. So it is mostly depend on the objects how we are going to create the physical world in the virtual space and what kind of objects we are going to use and how we are going to interact and how we are going to design the virtual space using the real world or the physical world objects, and how the movement and the position and how it is traveling around or across the virtual environment which we are creating. So here we will be enabling the accurate positioning and movement of the objects in the immersive environment. So these homogeneous transformation matrices are represented in 4 by 4 matrices, where upper left 3 by 3 matrix will represent the rotation and scaling components, and the rightmost column will represent the translation component. So by combining all these components, the homogeneous transformation matrix can be described for an object that will include its position, orientation, and how it is designed, right? So what are the various purposes that we use for homogeneous transformation matrices? So the first one is object placement, avatar animation, camera transformations, and object interactions. So how we are going to place an object in homogeneous transformation matrices are by using the orientation and position of that particular object within the virtual environment which we are creating by applying different types of transformations, and how we are going to rotate in that desired locations and orientations which we are going to create in virtual environment. So avatar animation, it is also like we are going to animate avatars or characters within the immersive environment by updating the transformation matrices over particular period of time, so that it will transform that movements into realistic, and the gestures will in response to users input, so that it is like predefined animations when we create it. And camera transformations, so here the position and orientation is very important to create or change or update the matrices while we are using the virtual camera within the virtual environment, so that it will give the appropriate transformation matrices where we can adjust and we can change and we can update, right? And the next one is object interactions. So here we are going to calculate if there is any collision detection, and we will give response between objects within the virtual space which we have created. So by giving the objects coordinates, we have different coordinates, right? So that we will be accurately giving whether it is interacting or whether it is colliding with each other within the objects, right? So the next one is object position. So how we are going to position an object in the environment which we are going to create, right? So here it may be according to the based on the location or based on the orientation of an object. So it should be accurate whenever we are positioning an object, so that it will help us to create a realistic and very interactive experience for the users. So we have different techniques. One is translation, rotation, scaling, and parent child relationships. So all these techniques we will be using for object positioning to experience the virtual environment, immersive environment. So object positionings, we have coordinates, right? X, Y, and Z. So by using these along with other axes, we will be translating the object position, and the rotations we know we will be using this X, Y, Z axes, or yaw, pitch, and roll rotations we will be using, so that we can change the position of an object. And scaling is like we are going to adjust or fit to that particular size which we are going to give to that particular object, so that all the dimensions will fit into that particular size which we are going to give, right? And the next one is parent child relationship. So it is like an hierarchical structure where parents object position will affect its child objects, right? So here the positioning and the movement of objects within the immersive environment will be having a parent child relationship. So these techniques we will combine and apply for this homogeneous transformation matrices, so that the object's position, orientation, and its scale will be accurate when we place it in the virtual world. So we can dynamically also update the object position according to the user's interaction or the animations which we are going to use here. And the next one is transformation invariant of immersive environment. So in this transformation invariant, we have different types of variations and properties and the characteristics of the environment, so that it won't remain unchanged whenever we transform certain characters or the positions or the properties, right? So we can provide important information and stability for various applications in immersive environment, like object recognition, tracking, and interaction. So we have a few common transformation invariants. It is based on scale invariance, rotation invariance. So if we take an algorithm where we do not change when the size or the scale of that particular object within it when it is modified, right? Particularly when we are using some applications like we are going to recognize an object or track where the size of the object may change according to the algorithm which we are using, right? And the next one is rotation invariance. So here it will remain unchanged whenever even the environment or the objects are rotated. So in this task we will use the different orientations, but it will not change. It will be in the form of unchanged while we are using a particular algorithm. And the next one is translation invariance, perspective invariance. So this is not affected whenever we are going to change a position or the location of the environment of the objects within that particular virtual environment which we are created. So here it may move within that particular virtual space which is created, but it won't affect the changes when we are exploring or when we are across the virtual space which we are created. And in perspective also, users point of view will be taken, or the cameras which will capture the 3D objects, it will take into the consideration whether it should change or not. So in perspective invariant, according to the user, it won't change its recognition. So we need to understand here how we are going to create a scene. So here the transformation invariant is used for developing algorithms and techniques, so that will give reliable results in immersive environments. So here we will be mostly using an algorithm called scale invariant feature transform, so that we will be used for a rotation invariant or object recognition. So all these two algorithms can be used to identify and track the objects in the real time within the virtual environment which we created by using a real world or the physical world. So the next one is object hierarchies. So in object hierarchy, we are going to design how we are going to structure and organize objects within the virtual space, and how efficient we are going to manage it and interact with the environment. So here we can define the relationship between different objects. Mostly we will be using parent child relationships. So the hierarchy will be determining here how it is transforming and how the movements are applied to an object within the environment which we are going to create. So here in hierarchy we can create a logical structure that will help us how objects will relate to each other and how they behave in response to user interactions or external events. We can define by using these hierarchies. So the first one is a parent child relationship. So here whenever we have an object, so whenever a child object will inherit the transformations, it will inherit from its parents, not from other objects. So this hierarchy transformation will help the movements or the rotations that will be applied to the parent object are given to its child objects. So this is how parent child relationship works in object hierarchy. And the next one is transformation propagation. So here it is applied to the parent object, so it will be automatically applied to the child whenever we are applying some specifications or some requirements in a parent child relationship. So here we can help to create the complex animations or the movements within that environment. So how we are going to interact and how we are going to manipulate, so all this object hierarchy will influence how objects are interacted and manipulated within the immersive world. So if we select a parent object, so if we select only the parent object, it might select all of its child objects for allowing convenient group of interactions within that particular hierarchy, right? So the next one is scale, perspective, and perception for immersive environment. So perception, perspective, scale. We need to know what is the difference between all of three, right? All of these three. So if we take avatar, self, embodiment, and distance perception. So here we will be using an avatar in VR so that it will enhance the distance perception accurately. So here the perception of scale and distance can be influenced by using the embodiment of a virtual body. And the next factor is spatial factors and perception. So here we will be having a spatial factors like distances, sizes, and proportions within the virtual environment. So here we will be using this for designing decisions and how we use these factors for creating a virtual environment, right? And the next one is risk perception and immersive environment. So here we are going to study and explore how immersive virtual reality experience will affect the risk perception, specifically forming focusing on storm surge flooding. So how we are going to scale and how we are going to use immersive environments to influence the risk perception that can be valuably used in designing and effective simulations in educational experiences. So if we take this body size estimation and visual perception, so it will influence how we are going to perceive the size of the body and how we are going to investigate the individual own body weight, shape, and based on the avatar representation. So these findings will help us to give importance for considering perspective and avatar embodiment while designing VR experience that will involve in body perception. So the next one is users perspective and cognitive task loads. So all these are used for immersive environments to design the objects, right? So the next one is physical modeling for immersive environment. So here we are going to create and integrate with the physical objects or the structures so that we can experience the virtual reality or the augmented reality. So here we need to have a training and simulation, collaborative experiences, haptic feedback, and enhancing immersions, right? So while we are using a physical modeling, we need to give a sense of presence and a sense of immersion so that the objects or the structures that we are going to interact with will give the experience of the real world experience that we are experiencing in virtual environment, right? So by combining both physical and virtual elements, we will be in a most engaging environment. So haptic feedback will be like users will be able to feel and touch the virtual objects or the surfaces. So this will add a sense of realism so that it will improve overall users experience. So we have different haptic devices like controllers, gloves, so that can simulate the sensation of touch and texture. So collaborative experiences is like if your multiple users can interact within the physical world simultaneously by communicating and interacting between participants. So there are particular useful fields where we can use this collaborative experiences like architecture, design, and engineering. So these are the physical modeling. So hybrid environments is like we are going to integrate physical modeling with hybrid like both physical and digital elements. So this will allow the users to interact with the real world objects. So the virtual content will be experienced through users. So here we can experience exhibitions or museums or interactive installations in hybrid environments. So, what are the challenges that we face with the physical modeling? Is like sometimes it won't be synchronized and it won't give accurate results between the physical and virtual environments. So, the requirement for robust tracking system, we need to ensure that the alignment and the interaction between the physical world and the virtual world is same when we are going to experience the virtual environment. So the next one is collision detection. So we have collision detection, surface deformation, force computation, force smoothing and mapping, haptic texturing. So this all comes under the physical modeling of physical world, module 4. So collision detection, surface deformation, force computation, force smoothing and mapping, all this will come under modeling the physical world concept. So this we will discuss in next class. Thank you.